Hey everyone, and welcome to this explainer, where we are diving into one of the absolute cornerstones of modern JavaScript, classes. If you've ever wanted to bring some serious structure and organization to your code, you're in the right place. We're going to talk about how to create blueprints that can turn messy code into something way more elegant and powerful.
So let me ask you this. Have you ever been deep in a project and it just starts to feel chaotic? You've got functions over here, data over there, and nothing feels connected. It gets tangled, hard to follow, and even harder to change. Yep, we've all been there. But don't worry, there's a fantastic solution for this exact problem.
And that solution is the class. Now, the key word here is blueprint. A class isn't the final house, it's the plan to build the house. And what's so great about this plan, it bundles everything together. The data, which is like the building materials, and the functions that work on that data, which are like the tools and instructions. It's all in one neat, self-contained package.
Okay, so first things first, what is a class really? Let's start by laying the foundation. So check this out. Here is our very first, very simple blueprint, a class called user. That special constructor method you see, think of it as the ignition. It runs automatically every single time we create a new user. Its whole job is to set up the object, and in this case, it just takes a name and sticks it onto the user. And then we have greet, which is a method or a function that every user we make will know how to perform.
So how do we actually use this blueprint? Well, it's pretty much a two-step dance. First, we use that new keyword to actually build the thing, to create a real object, or an instance of our user class. We'll call her Alice. Then, once Alice exists, we can just ask her to do things, like call her greet method. And that's it. That's the core loop. Build it, then use it.
All right, this next part is a really crucial distinction. So let's break it down. We've got two flavors of methods. Instance methods, like greet, belong to a specific object you've made. Alice can greet, Bob can greet, it's their action. But static methods are different. They belong to the class blueprint itself. They're like utility functions that are related to the class, but you don't need a specific user to call them. You call them right on the user class.
Okay, so making a basic blueprint is cool, but here's where classes get really powerful. What if we want to take an existing blueprint and make a special version of it? This brings us to the amazing power of inheritance. And this whole idea is called inheritance. Think of it like this. You're not starting from scratch. You take an existing blueprint, the parent, and you say, I want everything that one has, plus some extra stuff. The new child class gets all the parent's features for free, and then you can bolt on new features or change existing ones. It's all about not reinventing the wheel.
And here is what it looks like in practice. We're creating a new admin class, and notice that magic word, extends. That's what links it back to our user class. Then, inside the admin's own constructor, you see super name. This is so important. It's basically saying, hey, run the original user constructor first to handle the name, and then, once that's done, we'll add our own new admin-specific stuff, like permissions. We're literally building on top of the original foundation.
Now look at our new admin Bob in action. He can still do everything a normal user can, but notice how he's a little different. He overrides the greet method to give a special admin greeting. And he gets his own unique powers, like this has permission method that a regular user has no idea about. He inherits the basics and adds his own special flavor.
Okay, so building objects is great, but protecting the data inside those objects is just as important. So now let's shift gears and look at how classes give us fine-grained control over our data, making our code way safer and smarter.
This is where getters and setters are a game changer. Take a look at this temperature class. Inside, we're storing the temperature in Celsius, but see that getFahrenheit method? We've made something that looks and acts like a simple property, but behind the scenes, it's actually running code to do a calculation every time you ask for it. A setter would do the opposite, letting us run logic whenever someone tries to change the value. And the reason this is so cool is right here. It encapsulates the logic. It means someone using your class can just say temp.Fahrenheit. It's simple, it's direct. They don't have to know or care that you're doing a bunch of math behind the curtain. You get to hide the complexity and keep the public interface beautifully simple.
All right, now for something really, really powerful in modern JavaScript. true privacy. You know, for years, developers would just use a little underscore in front of a property name as kind of a hint, like, hey, please don't touch this. But now, with this hash symbol, or #, we can create fields that are actually private. No more hints. This is a locked door.
So you're probably thinking, if it's private, how is it useful? Well, the class itself gets to control access. It can provide a safe public doorway, like this getter we've called value, that lets the outside world read the internal state without being able to mess with it directly. You get to decide exactly how your data is accessed.
But what happens if someone tries to be sneaky? What if they try to bypass your public door and just grab that private count field directly? Boom, you get a syntax error. This isn't just a friendly suggestion anymore. The JavaScript language itself steps in and says, nope, you can't do that.
And that right there brings us to the main event. This is what true encapsulation is all about. You're building a protective shell around the internal workings of your object. This prevents bugs from accidental changes and makes sure your object is always in a good, valid state. You expose a clean, simple API and hide all the messy details inside.
Phew, okay, we've covered a lot of ground. Extends, super, getters, the hash symbol. Now let's just take a step back and see how all these little pieces of syntax connect to the grand principles of object-oriented programming, or OOP.
So here's a quick recap of the tools in our blueprint-making toolkit. The constructor kicks things off. Extends is our key to inheritance, and supergeep lets us call back to the parent. Getters and setters give us that computed property magic. And of course, the hash prefix gives us that real-deal privacy. These are our fundamental building blocks.
And this is the aha moment. This slide connects the how to the why. Each one of those tools we just learned maps directly to a core principle of OOP. Our private fields and accessors, that's encapsulation. The extends and super keywords, that's inheritance. And when our admin had a different greet method than a user, that's polymorphism. See? It's not just a random collection of features, it's a whole design philosophy.
So, as we wrap up, I'll leave you with this question. Now that you've seen how these blueprints work, how they can make your code cleaner, more reusable, and more secure, how could you use them to bring more structure and clarity to your next project? It's definitely something to think about. Thanks so much for joining me.